Greetings, everyone. By now, you have a good understanding of the one-sample t-test and the independent samples t-test. Here, I'm going to present a research scenario. Can you figure out what is the appropriate statistical procedure to use? A psychologist randomly selected 30 patients with depression to receive a 2-week treatment in which a new approach of daily intervention would be experimented. All patients were asked to complete an instrument that measures their depression symptoms before and after the treatment. The instrument is scored on a scale from 0 to 40, with higher scores indicating more severe symptoms. The psychologist hypothesized that because the treatment is intensive, patients' depression would be significantly alleviated after 2 weeks. There is only one sample, so would a one-sample t-test work? Not really, because there are two measures, the pre-test and the post-test. But an independent samples t-test would not be appropriate either because the two measures are not from two independently selected samples. As such, we need to learn a new t-test, the dependent samples t-test, also known as the paired samples t-test, in order to complete this task. A dependent samples t-test is a statistical test used to compare the means of two related groups of samples. It's used to determine whether there is a significant difference between two sets of observations that are paired or related in some way. In a dependent samples t-test, there is one dependent variable, which must be an interval or ratio variable. The variable is either measured twice from the same sample or measured from two samples that can be matched based on a certain relationship. An example of two measures from the same sample would be a pre- and post-treatment study, in which the same sample is measured twice. An example of measures from two groups that consist of matched pairs could be one group of husbands matched with their wives in a second group, or pairs of twins split to form two groups. The two groups are measured separately, but their answers can be paired based on the relatedness. Let's learn the dependent samples t-test using the above example. First, we need to state the hypotheses. Because the psychologist has a directional research hypothesis stating that the patient's depression would be significantly alleviated after 2 weeks. The test needs to be one-tailed. Thus, the null hypothesis is delta equals mu1 minus mu2 is smaller or equal to 0. And the alternative hypothesis is delta equals mu1 minus mu2 greater than 0, meaning the post-treatment measure is lower. Before we move forward, it's important to understand that what's being compared is not the two means calculated from the two sets of raw scores. Rather, the differences between the paired observations, that is, the difference between the two scores of each patient, are calculated. The mean of the difference scores is then compared with 0. If there is no difference between the pre and post measures, the mean of the differences is expected to be close to 0. If there is a change between the paired measures, then the mean of their differences should be significantly different from 0. In step 2, let's go with alpha equals 0.05. The sampling distribution in this case is based on the mean of the paired scores differences, delta. Assuming that all possible samples of the same size were taken, the means of the differences would form a t-distribution. Here, delta is a population parameter. The corresponding sample statistic is the small d with a bar on top. The sampling distribution of the mean of the differences has a mean of delta equals 0 and a standard error calculated as the standard deviation of the difference scores divided by the square root of sample size n. Later, I will show you in SPSS that in our example, the mean of the differences between paired scores is negative 1.5, and the standard deviation of the differences is 0.974. We then can find out that the standard error is 0.974 over the square root of 30, the result of which is 0.178. With a hypothesized delta equals 0, the observed t-value is negative 1.5 minus 0 divided by 0.178. which gives an observed t-value negative 8.44. With alpha equals 0.05 and the degrees of freedom 29, the critical t-value for a one-tailed test is negative 1.699. Also, the p-value of getting an observed t negative 8.44 is lower than 0.001. Either through the comparison between p and alpha or between the observed and the critical t-values, the evidence leads to rejecting the null hypothesis. The conclusion is that given alpha equals 0.05, there is a significant difference with t observed equals negative 8.44 in patient depression symptoms after the 2-week treatment. To run the dependent samples t-test in SPSS, you need to go to Analyze, Compare Means, Paired Samples t-test, then bring the pair of variables to the right where it says pair 1. With the first measure as variable 1 and the second measure as variable 2. Click OK when everything's ready and the output window will pop out. In the first table, titled Paired Samples Statistics, you will see the mean and standard deviation of the two variables. In the second table, there is the correlation between the two variables. In the third table, titled Paired Samples Test, you can see that the differences between pre- and post-treatment scores have a mean of negative 1.5 and a standard deviation of 0.974. The standard error is 0.178. Together, they gave a t-value of negative 8.437 and a p-value lower than 0.001. To better illustrate the rationale, let me demonstrate the test in a different way. First, I calculated the differences between the paired pre- and post-treatment scores by computing a new variable called diff. Then, in the one-sample t-test, I compare the mean of diff with 0. In the output, you can see that diff has a mean of negative 1.5 and a standard deviation of 0.974. The t-test gives an observed value of negative 8.437 and the p-value lower than 0.001. They are the exact same values as in the dependent samples t-test output. This demonstration shows that in the dependent samples t-test, what's being compared is not the means of two measures. It's indeed a one-sample t-test that compares the mean of the differences between paired scores with 0. given the no difference hypothesis. The pairing in a dependent samples t-test is important because it controls for individual differences between subjects, which can be a major source of variability. We have now learned all three types of t-tests. If you have two samples that are independently selected from their underlying populations, the independent samples t-test is the right choice to test the equality of two means. If the data contains two samples that can be matched in pairs, or two measures taken from the same sample at two different time points, the dependent samples t-test should be used to test the equality between related groups or of two variables from the same groups. If there's only one sample and you would like to compare its mean with a given population mean, the one sample t-test is appropriate. Even though their formulas are very similar, you need to pay attention to the calculation of the standard error values.